So each one of these points that I'm going to show you is between 10,000 and as many as maybe 60 or 70,000 individual soil samples, okay? So what I mean by that, the points on this chart, every little dot on this line, for example, here at 5, this dot is the average of about, let's just say 50,000 soil samples. And for those listening, from pH 4 to pH 8, the extractable potassium is about as flat a line as you can make with real agricultural data. There is no change in extractable potassium between pH of 4 and pH of 8. These are on Kentucky soils only, okay? Mehlich-3. So, and then after 8, there's some funny things happen because we're going to have some precipitation of calcium at these higher pHs. And then after 8, I would not have much confidence with the Mehlich-3 potassium. But if you're above 8.3, you're in a very, very small minority of soils. You're in a small population. We're talking about maybe 1% or less of the population exists above 8.5, something like that, at least in Kentucky. So the 99% of the population is going to be between 4 and 8 pH, something along 4 and 8.3, something like that, okay? And pH doesn't affect extractable potassium. You can see it's a straight line right across the chart from 4 to 5 to 6 to 7 to 8. And that's about as solid a data set as I'm aware of. And this is not published yet. Unfortunately, I haven't had a chance to publish these data yet. But that is from the University of Kentucky soil test lab, that they have a soil test database that I pulled those data from and created that chart. So when he says on this chart here, potassium is going to go up from 4 to 6, and then it's going to be flat from 6 to 7, and then it's going to decline from 7. That's all just BS. It's just not true.